Welcome. In this module, we will discuss state reduction, a crucial process in the design and optimization of finite state machines. We'll learn how to minimize the number of states in these machines. State reduction simplifies their implementation and improves efficiency. Why is state reduction important? There are two main benefits. First, hardware efficiency. Fewer states require less memory and reduce circuit complexity, leading to more efficient hardware implementations. Second, cost reduction. Simplified circuits mean lower manufacturing and maintenance costs. Reducing the number of states helps in creating simpler and more economical systems. Let's define what we mean by equivalent states. Two states are considered equivalent if they produce the same output sequence for every possible input sequence. This means no matter what input you give, these states will always give the same output. Mathematically, we can say that state S1 is equivalent to state S2, written as S1 is equivalent to S2, if delta of S1, x is equal to delta of S2, x and lambda of S1, x is equal to lambda of S2, x. Here delta represents the next state function, lambda represents the output function, and x represents any input sequence. There are two primary methods for state reduction. First, the tabular method. This involves using state transition tables to identify equivalent states by systematically comparing their outputs and next states. Second, the partition method. This is a more systematic approach that involves partitioning states based on their output behavior and refining these partitions until no further distinctions can be made. Let's break down the tabular method into a series of steps. Step 1. Create a state table. List all states with their outputs and next states in a tabular format. Step 2. Compare outputs. Group states with identical output patterns. These are potential candidates for equivalence. Step 3. Check next states. Verify that the next state transitions for the potential equivalent states are also equivalent. Step 4. Merge states. Combine the equivalent states into a single state, simplifying the state machine. Let's consider an example state table to illustrate the tabular method. Here we have a state table with 4 states, A, B, C, and D. The table shows the next state and output for each state given inputs x equals 0 and x equals 1. For example, from state A with an input of x equals 0, the machine transitions to state B and outputs 0. With an input of x equals 1, it transitions to state C and outputs 1. Using the example state table, we can identify equivalent states. First, same output pattern. States A and C have identical outputs for both input conditions. So A is equivalent to C. Second, same transition behavior. States B and D have identical transitions and output patterns. Thus, B is equivalent to D. After identifying the equivalent states, we can create a reduced state table. The reduced state table now has only 2 states, A and B, where A represents the merged states of A and C, and B represents the merged states of B and D. Here's the reduction result. The number of states reduced from 4 to 2, achieving a 50% reduction. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.